good morning, and thank you for the introduction, but also thanking for inviting me here to present the Aramis project. I have to say I was asked as well for the Madrid session in June, but we were still at very exciting times in this project and we felt it's just a little bit too early. And now I'm very pleased to tell you that over the summer, especially the commercial team, but also based on all the technical work that we've done, we've been able to sign up emitters for the first launching part of this project, so up to 5 megaton per annum. So that's a major achievement. We're not there yet, but at least we have passed that big hurdle that gives us confidence that we will move on with our partners. Indeed, I'm a development manager, so I'm a reservoir engineer by background, but over the last 10 years worked mainly on development of oil and gas projects. And I took over this role, at least from the Shell perspective, 2 years ago to be the development manager for the Aramis project. It's a corporation between, we're not a joint venture yet, but it's a corporation between Shell, Total Energies, GasUnie and EBN. And GasUnie and EBN are both government parties in the Netherlands. And so far, Shell and Total Energies have been taking the lead in the development part. So, and my counterpart in Total does certain parts of the scope, and I do certain parts of the scope, and together we try to develop it. So that's a little bit of background. I have, there's an Aramis website, by the way. I'll show you I go just the link on the last page. But the intent of now you see the nice picture of the Netherlands. The intent of the Aramis project was to develop a sort of large, flexible, open access storage and transport network for the Netherlands. We want to be able to have multiple store operators join in at the network, but we also want to give emitters a chance to sort of enter the network. And we are aiming for a size of about 22 megaton per annum. We are looking beyond the Netherlands as well. So the first phase will mainly be Dutch emitters, but we also give opportunities to other parties to enter the system, like by boats or by inland waterways, or maybe even by this big pipeline that might be built from Germany towards the Maasvlakte area, because we are quite strategically well located. The idea is to use indeed the depleted fields. So I found all the previous presentations quite interesting. The depleted fields in the Netherlands, because we have quite a few of them, but they have their specific challenges, of course, as well. But that's the whole intent. We're also building on the Portals project. I don't know if people have heard about these projects, but Portals is a little bit smaller size project in the Netherlands that also plans to use a depleted field and will already build a compressor station and a sort of collector line onshore to connect to some of these major industries in the Rotterdam area. They are at the point of FID, but they have some permitting issues related to NOx deposition. So that's another challenge, I think, that we're facing across Europe. But hopefully they will be on stream in 25, and we will follow maybe 2 years later. So we're building on what they're building, but just expanding their facilities. But what we will build new is that we will build a terminal that can accommodate ships and barges. So that can be coastal ships or barges. And we will build this huge offshore pipeline to the stores. And the stores will be developed by different joint ventures. And Shell, I'm leading the store development of one of them, and Total Energies does another one, and there are other offshore operators linking there. I'll talk a little bit later on the challenges, but still pretty high level, but you can offline ask me more on the challenges of using these depleted fields and what is different on the dense phase. I think one thing I want to say already here is, because we are envisaging such a large-scale project and we still have to transport it over long kilometers, we have no other choice than to transport it in dense phase. And it will arrive at seawater conditions, so that's almost a given. So that's what we have to deal with in the wells as well, that we will have dense CO2 arriving at the wells at maybe 150 bars or so. But I can tell a little bit more about that in the next slide. We do have aquifers as well in the Netherlands, but they're not so fantastic as you have them in Norway and the UK, because the blocks are all broken up. That's why we could capture the gas, but for aquifers, we're looking at it, but it also has its challenges, let me say it that way. A little bit on the background of the naming. So I think there's a few projects started in the Netherlands, Portos, Atos, and Aramis. They're all named after the three marketeers. And it was really starting from the perspective of the offshore store or field operators, hydrocarbon operators, that they said, like in the previous talk, we have all these empty gas fields and all that infrastructure. Can we not reuse it for purpose of abating CO2 emissions? And the map here just tries to show, at least around the Netherlands and in the Netherlands, where all the big sources of CO2 emission are. And the different colors on the maps are related to the type of industries. Like the red circles are the power and energy sector. The purple ones are chemicals. We have waste incinerators in the Netherlands that we will help, etc. The rest I think I've mentioned already, that it started off by Shell and Total, and then later the IBN and GasUnie joined us. This is another picture again of the infrastructure, but I thought I'll tell you a little bit more based on this picture on the challenges that we see. So I already said we have that very long pipeline. It will be about 30-inch, we think, or we've just taken the decision this morning that it will be 32-inch. Carbon steel, so CO2 specs maintenance is very important, otherwise we can't do it that way. And it will arrive at the wells in dense phase, because we try to avoid, of course, phase changes over the system. We are looking at depleted fields. I can only talk from the Shell perspective, but we've chosen a field that we think is just at the boundary limit, like 50, 60 bars reservoir pressure, so that we avoid the real cooling effects in the reservoir. But we will still need to design the wells such that there's no phase change in the wells happening. And because of that, you result, and people who've worked this will know it, you result in a well that has a very narrow operating envelope, like whether you put 80 or 180 bar at the tubing head pressure, the injection rate only varies by 10% or so, which gives a little bit of complexity, because the emitters, they want us to take their CO2 100% of the time, otherwise they build all the plants and we can't take it. So the availability that they request from us is really high. And we are worried, because we know emitters will have shut-ins and variations, etc. So how can we ever manage that over this long distance? So the combination that we now have with vapor CO2 coming in by a pipeline on the Maasvlakte, and there it's compressed to 180 bar, and shipped CO2 coming in by ships in cryogenic form and then stored in tanks and pumped to 180 bar, that gives us flexibility, because we can use the sort of terminal to balance variations in the gas supply to ensure we have a stable supply into the trunk line. And we've built, it's a very simple model still, but I'm still quite proud of it. We've used the sort of logistics team that normally helps LNG processes to expand that tool, including simplistic well behaviors, at least to show a little bit what the operating envelope is and how that changes with time, pressure, temperature, CO2 composition, to get a feel for how often in this system do we need to open and shut wells. And we came to a solution that we feel is workable or realistic. One more thing to say on this, just linked to the previous presentation, and linked to the 70% cost challenge. I think it's very difficult, to be honest. We also started this from a reuse perspective. I know we as Shell are seen as a little bit risk averse, but I think we have no choice to make this project succeed. But we've chosen to not reuse and to sort of go for a new platform and drill new wells, because reusing old wells from the 60s or 70s has a lot of complications. You can reuse some, but you really need to go into the detail of the original the cement bond logs, the casings, can they withstand these temperature cycles, etc.? And do you have place on your platform to drill new wells if your injectivity is poorer than anticipated? It's all linked to that availability demand from industry. They don't want you to only be up and running for 60 or 70% of the time. And availability comes at a price, so you can just do the calculations and see, is it worthwhile to drill another well to really meet the availability that they're requesting. So it's, I don't think it cannot be done, but you have to look at it case by case and see if it's feasible. I'm also worried about, but maybe I shouldn't say that here, but I think there will always be learnings, but every case that you look at has its specific challenges. So you always have to do all the work again before you can make the choice. I might be running out of time, but I thought this is a good linkage to what you discussed before. This is just a slide on the Dutch climate policy. I think the Dutch government is very keen for this project to happen, and they have the required subsidy schemes in place as well to help the industry sort of make the investments. We are targeting over 50% CO2 reduction. It's all linked to the Green Deal by 2030. It's all on the government website as well, but I thought it's always good to link it to the project. That's the goal from 1990 onwards to 2030. We are currently halfway, but in order to get there, we still have 20-25% to go. And the right-hand plots, and I don't know if you can read it, but shows how it's sort of distributed over the different sectors. And the second bar, the grayish bar, is industry. And if you see what the target is for Dutch industry to meet, it's about another 10 to 50 megaton per annum by 2030. So I think our Aramis project will at least, at launch, hopefully abate 5 megaton per annum, but we are really, together with Portals, trying to help make this target for the industry work in 2030. High-level timeline, I've already mentioned it in a few words, but I think we've been working this for the last 2 years officially, but I think within Total Energies and the NAM at the time in the Netherlands, it started a bit earlier. We are about to take concept select over the full value chain, and we hope we start the FEED phase next year. Construction maybe 25, 26, and we hope to be up and running in 27, I would say. That's our current goal. A little bit more on, but this is really on what are we building then. So a little bit more on the infrastructure. So on the left-hand side, you see a sort of picture where we zoom into it's the industrial area at Rotterdam, at the North Sea. So the good thing is, there's a high population in the Netherlands, but at least this area is designed for industrial use, so that helps us with the safety studies, etc. Let me say it that way. So we will have ships and the barges arriving there. The sizes are to be determined, but they could carry maybe up to 10,000 cubes. In these barges, it will be sort of very cold and 15 bars. And the CO2 will arrive at the tank farm and be loaded in the tank farm there, and then later on pumped into this big trunk line. And on the right-hand side, you see a picture zoom in of the different locations. I don't know if you can, is this a mouse? But anyway, where you see the 3, that's likely where the terminal will be built. Where you see maybe the little 1, that's where we will build the compressor station. And then 4 and 5 are options where we can, but maybe it's this one, isn't it? But I'm never very good at pointers.
That was the slides, and that one just the...
Is this the pointer, the top one?
The top one seems to be a little light.
Oh, sorry.
I've moved your slide, you
Oh,
the
yeah.
back one.
Oh, wrong way.
Sorry.
No worries. Yeah, so this is, there is an existing LNG terminal here, so the CO2 terminal will be very likely built in this location. This number 1 is where Portals will build its compressor station. So the idea is to transport liquid CO2 into the compressor station, mix it with the sort of compressed vapor CO2, and then follow, this is an existing pipeline corridor, to sort of the beach landing. And from here we will start, which is a very difficult project, drilling or building a tunnel under the Maasgul, and then finalize sort of the 200-kilometer length towards the fields. Then a little bit on the offshore infrastructure. So this is where the trunk line then will leave sort of the Rotterdam area. Yeah, and it's quite, I didn't know it was so busy in the North Sea, but there are lots of other destinations for the North Sea. So by selecting the routing, you have to take into account the nature areas, scent-winning areas. There's lots of wind farm developments there as well that are competing. Lots of ship anchor areas that you need to take into account when you select your routing. And there's also a lot of bombs from the Second World War that we need to avoid. So we're currently started to do some of the surveys to enable this routing. And then finally, I have one very simplified geological map for you. People who know the geology in the Netherlands, so we are now, for the first stores, targeting sort of the reservoirs just below the thick Zechstein formation. So we have a very thick salt layer that is providing the seal to the stores. And above that, we have multiple other seals as well. So I think containment-wise, we are very confident that we can store the CO2 there. For the 2 launching stores, we've just over the summer submitted the 2 storage permits to the Dutch government, and I think in due time it will be sent to the EU as well for approvals, and we hope somewhere next year to get these permits granted to enable us to take the investment decision late 24. So that's what I had to say. Thank you for your attention.